Yeah, I made some changes to the Pentode Class A1 Designer. We'll go ahead and talk about those. Remember, this is the design tool I came up with that runs ngSpice in the background and interactively plots load lines as well as the plate characteristics. So we'll go over and we'll clone this thing. And it's a Python program written in Python 3, so we'll go ahead and run it. Here it is here, and it still works the same way that it did before. It's interactive, so every time you change something, it reruns ngSpice in the background. And you can move your load line around. You know, this one is for an inductive load, where we have a load impedance that's reflected onto the plate from the your speaker load at 22K. And from here, you can measure your power output by clicking and dragging the range on your load line. And I already showed you a video of this before. But what I added to this was the ability to change this inductive back over to just straight resistive. So now, if we look at the load line over here, changing the plate current moves your bias point back and forth on the load line. So you can see that you're moving it back and forth over here. And also everything else works. So when you pick your load line, the load line is limited to the plate voltage over here, the supply voltage that you're supplying your stage amplifier with. And in this case, we're at 250 volts. So when the plate current is 0 or 250. And over here is when we have, this is our limit on the current for our load line. And this slope of this is actually 1 over the negative of 1 over the load impedance. So from here you can move the screen voltage around and kind of see how the load line lies on top of the plate characteristics, so that when you pick your bias point, you can decide where you actually want it. Whether you want it, up here where it's going to be in saturation, and over here it's going to be in cutoff. So remember, when you apply a voltage to the grid, you're going to swing on this load line. Now this load line, the green one here is the load impedance for 22K. This one over here is half of that, and this one over here is twice of that. And we can see that by dragging this around and making it kind of larger. And it just basically changes the slope of that green line. And you can decide what kind of load impedance you want. And then let's say you decide that this is where you want to keep your bias point, and you're having let's make this like a 20K resistor, and you want to apply a 1 volt amplitude waveform to the grid, which means you're going to go between like these two lines, because this is 0, -1, -2, -3, and you're going to be operating in this region here. So if you apply a 1 volt to the grid, you can come over here and click and drag down to here, and this will tell you the delta V. So delta V is actually 42.5. So that means our gain with a 20,000 ohm resistor is about 42. And if we want to make that gain a little bit higher, then we probably need to change this slope a little bit, and then move our load line back down like here. So 1 volt drop across here would be from here down to here on the load line, and that's now 57 volt, which means our gain is now 57. This is all voltage gain. So this is kind of a big addition. So what we can do with this is actually we can design both voltage amplifiers as well as output stage amplifiers with the different tubes that are listed here. Okay, well, hope you enjoyed it. Thanks for watching.